Hi, this is Josh again with a quick video prep for your TI-84 calculator. In the last video, we used the calculator to find the zero values on a graph using an upward and downward parabola. I'm here with those same parabolas that I've written here. We're going to now find the location of the vertex for each graph. So if we go to the graph itself and hit trace, we can trace along the blue line. And where's the drone? Here it comes. We can see that I'm approaching the lowest point, which is the vertex. It looks like the vertex is somewhere near 3, but because of the step count, we're not really finding the actual true location of the vertex. Similarly, if I go to the red line, and I go all the way up to the maximum, because it's the downward parabola of the vertex, it looks like it's somewhere between 0 and 1. Because that's 0.3, that's 1. So it's somewhere up there between 0 and 1. But if we want to find the true location of the vertex, we can use the calculator tool. So second, trace. For the first equation, the blue equation, it's a minimum. So we want to do calculate minimum, which is choice 3 on the menu. Again, move the drone to the left of the minimum, hit enter, and it will put up a column post. That's our lower bound. Then move the drone to the right, make sure we're to the right of the minimum. Now we're increasing, the function is increasing, hit enter. Now we have 2 columns placed with the minimum trapped in between it. Lower and upper bound, the minimum is somewhere there. Hit enter again. And it says the minimum is at 2.99994, comma -4. Well, those 6 nines actually 4. So the computer is really saying it's at 3, -4. And we'll confirm that with the table, and we can confirm that algebraically. But because of the computer algorithm, it writes 2.9999994. We want to find the vertex, so I'm just noting it's at 3, -4. Let's go to the other graph. Again, since it's the red line, that is a maximum, so choose choice 4. Again, I'm going to have to move the drone along the red line, but it's on the blue line. So remember to click up or down to switch graphs. So now I'm to the left of the maximum. Here it's still increasing. Make sure that it's decreasing, that you're on the right side, hit enter. Now we have a lower bound column and an upper bound column flagged. Hit enter again. And the maximum is at 4.999995. 0.49. So that's a half, comma 6.25. Okay, so those are the minimum and maximum as done by the TI calculator. What we can do is we can go to the table, and let's see, for the first graph, we can see that, well, the minimum is at, for the blue graph, is here at 3, -4. And if you remember how to graph a 7-point parabola, if you do 3 points before, we get 5, 0, and -3 for our outputs. Well, if you do 3 points after the vertex, due to the symmetry of the parabola, we also get in reverse -3, 0, and 5. That's because, as you can see on the graph here, I'll draw it with an arrow. You can see that, well, there's the vertex, and those are 3 points going up on the left branch, and also 3 points increasing on the right branch from the vertex point, which is this star point down here at the bottom of the quadratic. Okay, that's the turning point of the quadratic. So due to the symmetry, we get those same values on the left side of the vertex and the right side. Well, what about not the blue graph, which shows the 7-point parabola right there on the table, but the red graph? Well, the problem here is that the vertex for the red graph was a half. So if I go to the column here, you can see that for the red graph, a half is the midpoint of 0 and 1. But we do know that any points on the left side should be symmetric or the same values to points on the right side. So indeed, we do see that as we step away from the vertex by a half step, by 1.5, by 2.5, by 3.5 steps, those are the same y values. Because here, if I plot it on the graph, that's analogous to me drawing these horizontal bars at different heights. You'll see that on the left side and the right side, that the parabola has the same value for those y values. Those same, excuse me, so the same two y values equally distant from the axis of symmetry. This is symmetric. But how do we express this on the table? Well, one way of doing that, if you've done this with your teacher in class, is go to second table settings. And then instead of having the increments as 1 unit, we can make them a half unit. Then when we go back to the table, well, we know that the axis, that the vertex is on the axis of symmetry at a half. But now the domain is skipping by half steps. So now when we look at the red graph, well, we know that a half, 6.25, is the vertex. But these three values to the left, 6, 5.25, and 4, are in reverse down here due to the symmetry as we do half steps away from the vertex, the 7-point parabola. Other teachers, they don't teach scaling the domain values so that they're in some step that is useful for the location of the vertex. Okay, since it was at a half, it makes sense to set the domain as half steps. But some teachers also teach that, well, you can, if it's at a half step, change the table settings to ask, well, we know that the vertex is at a half. But if I enter -2, -1, 0, then a half, then 1, 2, 3. This is another 7-point parabola, but you can see that some teachers like to do this because if the vertex is at a half step, then you're back to integers by just doing a half step first. Then the values that are away from the vertex and in both directions are all on lattice points, or the domain values are on lattice points. They're all integers. And as you can see, because it's symmetric, for these values, we get 6, 4, and 0 going away from the vertex, and 6, 4, and 0. But the vertex itself is at a half, 6.25. I hope that this video was useful to you for preparing for your upcoming SAT and other standardized exams. Thank you for watching my video.